This is 2015 question 5. This is a graph analysis problem here. First thing that I would look at is knowing what the graph represents here. So in this case, it's the graph of f prime. Okay. If you read through this text here, some things that you should note. Notice how there are horizontal tangents at x equals -1, 1, and 3. That's pretty much indicating where the graph is changing directions, but not as important as this next part here, indicating the areas of the regions. Okay, so from -2 to 1, from 1 to 4, the areas are going to be 9 and 12. You guys do have to understand that it's below the x-axis, so this is actually -9 and -12 there. So that's all we need for now. Let's jump to the first one. We want to find out what x-coordinates where f has a relative max. So remember, relative, again, means local. So remember, f will have a local max if f prime changes from positive to negative. Okay, so where does the graph of f prime do that? Okay, so notice how right here the graph is changing from positive to negative. Here at 1 it's from negative to negative, and at 4 it's just from negative, and we don't know what happens after. So it's only going to happen at this location here at -2. And there you go. They mention all the critical numbers. It's really not necessary, but it's up to you. Okay, here's part B. Part B, what open intervals from -3 to 4 is the graph of f both concave down and decreasing? Okay, so just like the previous year's FRQ, we'll break it down like this. We want to find out from -3 all the way to 4, so pretty much the whole graph, okay, where f is concave down and decreasing. So let's go ahead and write that down, okay? We want to know where f is concave down, and we want to know where f is decreasing. Notice how you only have the graph of f prime, so we have to translate these two statements into something that we can understand. So we know that f prime is going to decrease when f is concave down, and we know that f prime is negative or less than 0 when f is decreasing. So let's take a look at these two statements here. So f prime is decreasing. The graph is literally going downwards here in orange. Okay. And f prime is less than 0 or below the x-axis here. So where do the two overlap? So it's looking like from -2 to -1, and from 1 to 3. And that's basically it. We know this because f prime is decreasing and negative at these intervals. That's basically what we did up here. Okay? Part C, find x-coordinates of all points of inflection for the graph of f. Okay? Give a reason for your answer. So right away when I see points of inflection, I think of the second derivative, okay? So pretty much this is where the second derivative changes signs. But again, we only have the graph of f prime. So this is equivalent to saying where f prime changes directions. Okay, how often does this graph of f prime change directions? So it should be 3 different times. One right here, and right here. Okay, so that indicates that there's going to be 3 points of inflections. Now, how do you explain this? You could say at x equals -1, 1, and 3, since f prime changes directions. Okay, they went a little bit further by saying that how they actually change the directions, but again, it really doesn't matter. Okay, last one, part D. Given that f of 1 is 3, write an expression for f of x that involves the integral. Okay, And then they ask you for the second part here, but we'll get to that in a second. So the way you want to break this down is we want f of x. Okay? So we definitely have to integrate f prime of x to go back to what we started with, okay? So we want to go as far as x, where however far we want to go. But we have to consider where we want to start. And your start is pretty much the given condition. F of 1 is 3. So we want to go from 1 all the way to x, some number x, okay? But you also have to consider where you start, because this is just pretty much your movement or your accumulation. But you also got to consider your starting value. So at 1, f of 1 is really 3. Or you could just write f of 1. I'll leave that up to you. But that's basically how they got this right here. Okay? So if you want to find f of 4, you're pretty much replacing an x with a 4. Okay? And if you want to find f of negative 2, you're replacing x with a negative 2. All right? Now, what does this all mean? It's going to be 3 plus this. You have to understand that integrating a graph is really just finding the area. Okay? So what is the area from 1 to 4? So let's take a look at our graph. So from 1 to 4, the area was listed. It was negative 12. Okay? Which is where they get this from. Equals equal. You could stop there. From 1 to negative 2, notice how that's a little bit backwards. From 1 to negative 2, okay? So what they did in the scoring guidelines was they actually flipped it properly, but you account for a negative, all right? Now, if you go from negative 2 to 1, it was listed that the area was negative 9. So 3 minus negative 9 comes out to positive 12 or equals equal. But that's basically it.